Okay, so now I will be doing question 17. So the first important concept in question 17 is angular momentum, and specifically conservation of angular momentum. So basically, the angular momentum we're going to be discussing is angular momentum equals moment of inertia times angular velocity. So when it's just an object spinning around its own axis. So angular momentum will be conserved when it's in an isolated system. So that means no energy is leaving or entering the system. It's an isolated system. So that's the condition for angular momentum to be conserved. So we can say that moment of inertia times angular velocity initial will be moment of inertia times angular velocity final. So that's conservation of angular momentum. Okay, the next principle I will be exploring is elastic and inelastic collisions. So both of these types of collisions will have momentum conserved in them. However, for an elastic collision, both momentum and kinetic energy will be conserved. So that means the total kinetic energy beforehand will be equal to the total kinetic energy afterwards. In an inelastic collision, it means that kinetic energy is not conserved. And one special type of inelastic collision is perfectly inelastic collision, where the objects stick together and then they move at the same velocity together at the end. Okay, so that's elastic and inelastic collisions. Elastic collisions are not very common, or basically not common at all, because kinetic energy is almost always lost to the system. So now I'm going to read question 17, and this connects to the 17 through 19 questioning. Which of the following properties of the two-disk system must be conserved between the time the second disk is dropped on the first disk and the time that the two disks begin rotating with the same speed? Okay, so basically in this problem, there's two disks like this, and one disk is at rest, and another disk is moving with a certain angular velocity. So one is rotating, one is just standing still. And then they get dropped onto each other, and then they move at a final angular velocity together. So we can see here that this is a perfectly inelastic collision, because they're sticking together and then they're moving at a final angular velocity. So that means that it's an inelastic collision. So what we know from that is that kinetic energy is not conserved. So we can rule out all the answers that say kinetic energy is conserved. And then, is angular momentum conserved? So yes, angular momentum will be conserved because it's an inelastic collision, and it's an isolated system. We know this because there's no external forces acting on the system, so we know that it's going to be isolated. So we know that the answer to question 17 is then answer B. And answer B states that only angular momentum is conserved. So basically, in conclusion, this question shows important concepts of angular momentum, specifically that angular momentum, it's only conserved in an isolated system. And then we also learned important concepts of elastic and inelastic collisions, and how in an elastic collision, kinetic energy is conserved, and in an inelastic collision, it's not conserved. And in this question, we had an inelastic collision, so the kinetic energy we had an inelastic collision, so the kinetic energy was not conserved. So that means only angular momentum will be conserved.